Okay, when we simplify, we have to find an LCD, and then both fractions have to have the same denominator. Okay, so when we are simplifying, we find the LCD, and we're going to put the LCD here, and we're going to put the LCD here. Okay, the second problem says solve. Our directions say solve, and we have an equal sign right here. We're still going to find the LCD, but for the second problem, we are going to multiply everything by the LCD to eliminate the denominators. Okay? So on our first one, we're going to change both rationals so that they have the same denominator. In the second one, we multiply everything by the LCD to eliminate the denominators. Okay, and again, this particular chapter is intense. Be sure you're doing all the homework, and be sure that you're watching the videos as you need to watch the videos, and you're coming to the help session as you need to come to the help session. Okay, so just kind of be aware of that. Okay, let's do both of these. Now, I do want to find my LCD here. I want to find my LCD. I always ask myself, do I need to simplify this or break this down? Simplify is not the right word. Do I need to factor either one of those denominators? Do I need to break them down anymore? And can they be broken down? Can either one of them be broken down? No, they can't. Okay, so then I start to find my LCD. N minus 6 is a binomial. So it functions as a unit, n minus 6. That's part of my LCD. My second fraction has 2n plus 3. That's not represented at all in the n minus 6, so I have to write down that binomial as well, 2n plus 3. Now, I want to deal with this minus sign. I want you to start thinking about that minus sign from the very beginning. I am going to change my minus sign to a plus, and I am going to make my 6 negative. That is going to make the minus sign easier to deal with, and we're not going to forget about it. Okay, now we're going to get started with my LCD. So my first rational is negative 2 over n minus 6. So I have to decide what is missing from my LCD. What do I not have in my first denominator? Good, 2n plus 3. So I am going to multiply the top and the bottom by 2n plus 3. Now I'm going to do the same thing with my second rational. Okay, my 2n plus 3 is accounted for. What am I missing? N minus 6. Excellent. So I'm going to have n minus 6 on the bottom and n minus 6 on the top. Okay? Now, my common denominator is n minus 6 times 2n plus 3. I do not have to multiply that out. If you decided to multiply that out, that would be fine, but you don't have to. Now I've got to distribute my negative 2, so I end up with negative 4n minus 6. Then I've got to distribute my negative 6, so I am left with minus 6n plus 36. I'm not done because I have some like terms that I can combine. I have negative 4n and negative 6n. What does that give me? Excellent. Then I have negative 6 and positive 36. What does that give me? Good. So now I have my final answer. Yes?
On mine, I didn't put the 2 in. Like for mine, I just did negative 2 in. I don't know how to explain it, but I did it differently and I got the same answer.
I probably need to look at it after class just to make sure you're doing it mathematically accurately.
Okay.
Yeah, as long as you're doing it mathematically correct, it's okay. Okay, can we do the next one? For this one, we are solving. So what we want to do first is we want to break down our denominators as much as we can. What's the denominator with my 2? What's that 2 over? 1. Good. So I would go ahead and write that out right now as 2 over 1. Okay? Then I'm going to have 4 over x minus 2. Can the x minus 2 be broken down any? No. Then I have 8 over x squared minus 2x. That can be broken down, and I'm going to factor out an x, and I have x times x minus 2. Okay? Now, I need to find out my values that are not allowed. My values that are not allowed. Okay, those are my undefined values. Values that are not allowed are undefined. It makes the entire problem undefined if I get certain values. How do I determine that? What do I set equal to 0? Okay, so I'm going to do x minus 2 equals 0. Okay, because x minus 2 can't equal 0. If x minus 2 equals 0, it makes the fraction undefined. So x cannot be what? 2. Okay. I also have to deal with that x right there. Okay? What else can that x not be? It can't be 0, because if this x is 0, if I plug in 0 for that x, I would have 0 times 0 minus 2. That's 0 times negative 2. What's 0 times negative 2? 0. Okay, so these are my undefined values. Those are the things that I've got to look out for. If I get either one of those as part of my answer, what do I have to do? Throw it out. Okay? The next thing that I want to do is I want to find my LCD. Okay? In 2 over 1, do I need to write down the 1? I don't. Anything times 1 is itself, so I don't have to write down the 1. X minus 2 is going to be part of my LCD. Okay? I've already got the x minus 2 accounted for, so what do I need to write down for my third rational? The x. Okay? So what I'm going to do now is I'm going to multiply everything times my LCD. Okay? So I'm going to multiply x minus 2 times x. Okay, so I have 2 over 1 times x minus 2 times x over 1. I have plus 4 over x minus 2 times x minus 2 times x over 1. That equals 8 over x times x minus 2 times x minus 2 times x over 1. This allows me to eliminate all denominators, and that's what I want. I want my denominators eliminated. Okay? I don't have anything that can cancel in my first rational. My first expression doesn't cancel anything. I am going to write down x minus 2, but there are 2 things that I've got to multiply this x minus 2 by. I have a 2 and an x, and I've got to distribute both of those. So this is 2x times x minus 2. Okay? In my next one, I've got x minus 2 and x minus 2. What am I left with on my next one? Good. Okay. Then I have x minus 2 and x minus 2, x and x. So what am I left with? 8. Okay. Now I'm going to solve this equation. 2x times x is 2x squared. 2x times negative 2 is minus 4x. Then I have plus 4x, and that equals 8. My negative 4x and my positive 4x cancel. So I have 2x squared equals 8. Because it's a quadratic is anything raised to the second power, I have to set it equal to 0 in order to solve it. So I'm going to have 2x squared minus 8 equals 0. Okay? 2x squared minus 8 equals 0. What is a GCF I can factor out of that? 2. So I'm going to factor out a 2, and I'm left with x squared minus 4. What do you know about x squared minus 4? Excellent. So it's x plus 2, x minus 2. Okay? So now I'm going to set each thing equal to 0. I'm going to set 2 equal to 0, but I can immediately throw it out because there's no x in there. So I don't need to worry about that. In pre-calculus, you will sometimes have an x there that you want to worry about. Then I have x plus 2 equals 0 and x minus 2 equals 0. Okay? X plus 2 equals 0 leaves me with x equals negative 2. X minus 2 equals 0 leaves me with x equals positive 2. Students want to stop right there. Very, very often they want to stop. But they can't because they've got to throw one of these out. So you go back to this and see if either one of your answers fall into that. Do one of the answers fall into that? Which one? Good. So we have to throw that out. So this is my only solution. The answer to this is only x equals negative 2. Okay, can I go to the next screen? Okay. I want you to take about 30 seconds and I want you to divide. Go back to maybe 4th, 5th, 6th grade. We're going to divide. Okay, how many times does 7 go into 4? How many times does 7 go into 4? None. 0, okay? I could write a 0 here, but I don't have to. But I could write a 0 there. Okay, how many times does 7 go into 43? 6 times. So notice where I am writing that 6. I am writing that 6 above my tens place. I'm writing that 6 above my tens place. Okay? Now I do 6 times 7 is 42. What do I do now? What's my next step? Subtract. Okay? Now I want you to know this subtract right here is where students make mistakes all the time. That's the number one place that student makes mistakes when they're doing this. So be aware of that. Okay, 43 minus 42 leaves me with 16. How many times does 7 go into 16? 2. 2 times 7 is 14. I subtract again. Okay, I subtract. 16 minus 14 is 2. Okay? So oftentimes student will write this as 62 remainder 2. Okay? I don't want you to write it as remainder 2. I want you to write it as a fraction. So I would have 62, and I would have the 2 over what I am dividing by. So it would be 2 over what? 7. Okay? So my final answer to this would be 62 and 2 sevenths. 62 and 2 sevenths. Okay? We're going to use this principle to divide polynomials. We're going to use this principle to divide polynomials. And we're going to be, this is where you've got to make sure you do okay. It's with the subtraction. Students forget about that subtraction. So now we are going to do this division problem. I have 5x squared plus 6x minus 8 divided by x plus 2. We are going to use those same principles. We're going to use those same principles to solve this problem. Okay? So, my first question. X times what gives me 5x squared? Excellent. 5x. Okay? So I asked myself, x times what gives me 5x squared? Okay? Now, I'm going to do 5x times 2. Oh, and notice where I put the 5x. Do you see how I put the 5x over top the 6x? Okay, it's very similar to place value. 5x times 2 is 10x. 5x times x is 5x squared, which is what we want. Now, where did I say students make mistakes? They subtract. Students want to add here. They don't want to subtract. But you've got to subtract. So I've got minus 5x squared minus 10x. 5x squared minus 5x squared is 0. 6x minus 10x is minus 4x. My next step is to bring down my negative 2. I'm sorry, that's a negative 8. My next step is to bring down my negative 8. And then I ask myself again, x times what gives me negative 4x? Negative 4. So now I do negative 4 times 2 is negative 8. Negative 4 times x is negative 4x. What am I doing here? Subtracting. So I have to change my sign. What's minus a negative? Good. Minus a negative is a positive. So that becomes positive 4x, and this becomes positive 8. So negative 8 and positive 8 is 0. Negative 4x and positive 4x is 0. So my final answer to this is 5x minus 4. Okay? Can I move to the next screen? Okay. Okay. 2x squared minus 3x plus 1. 2x squared minus 3x plus 1 divided by x minus 5. So I am going to put the 2x squared minus 3x plus 1 inside the box. x minus 5 is going to go outside the box. Then I say x times what gives me 2x squared? 2x. Okay. 2x times negative 5 is negative 10x. 2x times x is 2x squared. Don't forget, we are subtracting. So this is minus 2x squared plus 10x. Negative 3x and positive 10x give me positive 7x. 2x squared and minus 2x squared give me 0. Now I bring down my positive 1. X times what gives me 7x? Excellent. Okay. 7 times negative 5 is negative 35. 7 times x is 7x. We have to subtract. 1 plus 35 is 36. 7x and negative 7x give me 0. This is the remainder. Okay, this is the remainder. I am going to write the remainder over what I am dividing by. Okay, I don't want you just to write remainder 36. I want you to write plus 36 over what I'm dividing by. That's how that works. Can I go to the next screen? Okay. T to the third minus 8 divided by t minus 2. T to the third minus 8 divided by t minus 2. I want you to start by looking at this t to the third minus 8. What do you notice that's different about that compared to the other two problems that we've done? It is raised to the third power. Excellent. That is definitely something that is different about that. What else? How many terms did the other problems have? They had 3 terms. If it started with x squared, what was the very next term? X. We are missing terms here. Okay? And this is another place that students make mistakes. I am missing an x squared. I am missing an x. Now, what can I put in front of that x squared and that x to not change the value? To account for the x squared and to account for the x, but not change the value. What can I put in front of that? Oh, how about a t? Would you like me to put a t squared and a t? Sorry about that, guys. What can I put in front of it? Okay. 1 times t squared is going to give me t squared. I want to get nothing. What can I multiply that by to get nothing? Yes. So I've got to have 0t squared plus 0t. You have to add in the missing terms because you've got to go from t to the third to t squared to t to your constant. If you don't have all of those, you've got to put 0 in for those. That's super important, and it's a very common mistake for students. So I want to put t to the third plus 0t squared plus 0t minus 8 into my box. Then I'm going to put t minus 2 on the outside. So I'm going to start by asking myself, t times what gives me t to the third? T squared. Good job. Okay? So now I'm going to say t squared times negative 2. That gives me negative 2t squared. T squared times t gives me t to the third. I'm subtracting, so I have to change both of those signs. I'm going to have a minus right here. This minus becomes a plus. T to the third minus t squared is gone. I get 0. 0t squared plus 2t squared is 2t squared. So now I'm going to bring down my next term. So then I have 2t squared plus 0t. T times what gives me 2t squared? 2t. 2t times negative 2 is negative 4t. 2t times 2 is 2t squared. I am subtracting, so I've got to change both of those signs. 2t squared minus 2t squared is 0. 0t plus 4t is 4t. Then I bring down my negative 8. T times what gives me 4t? Good. 4 times negative 2 is negative 8. 4 times t is 4t. I change each of these, and I'm left with 0 plus 0. So my final answer here is t squared plus 2t plus 4. Okay, on your homework and on your test, you're going to have a problem where you have to divide. For those of you going to pre-calculus, I want to talk to you about something called synthetic division. Synthetic division. Synthetic division is an easier way to do division of polynomials. You focus on the 0, you find the 0 that is associated with the factor. So we do that by setting the factor equal to 0. So I have x plus 2 equals 0. So what is x? Negative 2. Okay? And that's what we're going to put in our box, is the negative 2. Okay, so the first thing that we do is instead of using the factor, which is x plus 2, we find the 0 associated with that factor. Okay, and if my factor is x plus 2, my 0 is x equals negative 2. So I've got to find the 0 associated with that factor. The next thing that I do is I focus on my coefficients. I focus on my coefficients. I don't write down the x squared and the x. I just write down the coefficients. So I have 5, I have 6, and I have negative 8. 5, 6, and negative 8. Okay? So this is what a synthetic division problem looks like. My first step is to bring that 5 directly down. Okay, so I bring my 5 directly down. Then I multiply that number times what's over here in my box. So I have 5 times negative 2. 5 times negative 2 is negative 10. Okay, 6 plus negative 10 is negative 4. I multiply that -4 times the -2, and I get 8, correct. -8 and 8 is 0. So what I am left with now, this is my remainder. This is my constant. Constant means there's no x associated with it. And this is my x term. So I rewrite this as 5x minus 4. And is there a remainder? I have no remainder. So this is my final answer. Okay, and that is synthetic division. Can I go to the next one? Okay. We're going to do this one now as synthetic division. The first thing I have to do is I have to find my 0 associated with this factor. So I take x minus 5 and I set that equal to 0. What is my 0? Good. X equals 5. So that is what I'm going to put in my box over here is the 5. Then I look at my coefficients right here. I have +2, -3, and +1. I'm going to bring that 2 directly down. I multiply that 2 times 5. What is 2 times 5? Okay, -3 plus 10 gives me +7. I'm going to multiply that 7 times 5. 7 times 5 is 35, I'm sorry. 1 plus 35 is 36. So, this is my remainder. This is my constant. This is my x coefficient. So my answer is 2x plus 7. I have a remainder of 36. What do I write over that, or what do I write that remainder over? X minus 5. You write the remainder over what you're dividing by, which is x minus 5. Okay? Okay. The next one, we had missing terms. T to the third minus 8. We had to rewrite that as t to the third plus 0t squared plus 0t minus 8. You have to do that for synthetic division also. So the coefficients that I'm going to use in this synthetic division problem are 1, 0, 0, and -8. Okay? Now I've got to find the 0 that's associated with this factor. So I have t minus 2 equals 0. So what's t? 2. So that's what I'm going to put right here. You've got to remember to account for these terms. So don't forget to plug those zeros in. So I'm going to bring my 1 down. What do I multiply my 1 by? 2. 1 times 2 is 2. 0 plus 2 is 2. I'm going to multiply that by 2 again. 2 times 2 is 4. 0 plus 4 is 4. I multiply that times 2. 4 times 2 is 8. Okay, so I have remainder This is my constant. This is my x coefficient. What is the 1? Excellent, x squared. So my final answer here is 1 x squared plus x. Whoops, it's plus 2x. I didn't write my coefficient. So I have 1x squared plus 2x plus 4. That's my final answer to this one. Okay? Now, I want us to do some more review. Any questions on synthetic division? Okay, so what I want you to do right now is I want you to take 3 minutes to do this problem right here. 9 over 4x plus 1 over 3 equals 5 over 2x. We are solving this, so we need to be multiplying by the LCD. Okay, because we're solving this, we've got to multiply everything by the LCD. So I am going to first rewrite this and see if I can break down any of the denominators. So the first denominator is 4x. I could rewrite that as 2 times 2 times x. The reason that that is helpful is then I am able to see and make sure that I've accounted for every factor that I need to in the denominators. My next one is a 3, so I have 1/3. I can't break down the 3 any because it's a prime number. Then I have 5 over 2 times x. Again, my 2 is prime, so I can't break that down any further. So my LCD is going to have to account for all of these parts. So I have a 2 times 2 times 2, and then that's times x. 2 times 2 times x. Here, what do I have? A 3. Has that been accounted for yet? No. So I have to write down a 3. Here I've got a 2, and here I've got an x. Have they been accounted for? Yes. So I don't have to rewrite them again. Now, the next thing that I need to think about is my undefined values. Undefined values. Do I have some values that x cannot be? Okay? Is there a value that I could plug into x that would give me 0 in the denominator? It is. It's 0. So x cannot be 0. What that means is, when I solve this, if I get x equals 0 as my answer, or as one of my answers, I have to throw it out. That's what that means when I've identified an undefined value. Okay? So now I've got my LCD. Some students prefer to multiply by 12x. I like to keep it written out because then we're able to cancel very neatly. Okay? But if you like to multiply by 12x, our LCD is 12x. But again, I keep it written as numbers. I say, or as primes. 2 times 2 times 3 times x. So I'm going to multiply everything times that. So I have 9 over 2 times x. That's going to be multiplied by 2 times 2 times 3 times x over 1. Then I have plus 1/3 times 2 times 2 times 3 times x over 1 equals 5 over 2 times x, 2 times 2 times 3 times x over 1. Okay? If it's in the top and the bottom, I can cancel it. I have 2 and a 2 in both the top and the bottom, and I have an x and an x. So I'm left with 9 times 3. What's 9 times 3? 27. Okay, for my next one, I have a 3 in the denominator that I can cancel out, but I can't cancel out anything else. So I'm left with 1 times 2 times 2 times x. That is going to be 4x. Okay? Then I have a 2 and an x that can cancel, but I'm left with 5 times 2 times 3. 5 times 2 times 3 is 30. Now we have a much simpler problem that can be solved. I subtract 27 from both sides. When I do that, I'm left with 4x equals 3. I divide both sides by 4. My final answer is x equals 3/4. Is that an undefined value? No, so we're good. My final answer is x equals 3/4. Please don't pack up. Okay? This is I'm sorry? Do you need this for another minute?
Yeah.
Okay. This is an intense chapter. Okay? If you struggled with factoring, then you've got to kind of make sure you've got factoring to be successful in this chapter. Okay? This is intense. It is in your best interest to have your homework finished by Friday. Okay? It's in your best interest to have your homework finished by Friday. We're going to do a classwork assignment on Friday, and I'm going to talk with each student about your courses for next year. Okay? We have a quiz on Monday the 4th, and your test is on Friday the 8th. That's next week. We do have a help session today, and I'm going to be focusing on rational equations. Okay? I will see you on Friday.